We talk again about the air handling unit. Well, as you'll see in this picture here, you'll see some dampers which alternate. And here you'll see another type of AHU and also the damper opening and closing. Here, I want you to see the damper a little bit closer. This motor using two dampers, the dampers are interlocked with the motor usually, and I want to show you a different type of integration and different type of arrangement. Like you'll see in this movie, this motor can get air from one or the other dampers. They don't need a functional interlock, they need only a safety interlock. If one damper is broken and cannot open and the other one will be also closed, the motor will be like a block vacuum cleaner. It couldn't drag air and it will burn. That's why we interlock the dampers. This system requires a functional interlock because there's only one damper. If the damper it is not opening, the motor won't have any air to pull and it will look again like a block vacuum cleaner. So when the damper open, it will instruct the fan to run. So this is the interlock in between the damper and the motor. If you have a damper failure, obviously the motor will not run. And let's go a little bit deeper. Let's see how this damper working. If you have a faulty damper, the HMI will tell you what to do. So look into this video, you'll see a damper that is opening and is sending an instruction to the PLC. That's an instruction to the variable speed driver, and it will turn the motor on and the cooling heat exchanger like you'll see in this picture. And if there will be a fault on a damper and the damper will not open, the damper will instruct the PLC to hold off the motor, and the heat exchanger, you cannot run the cooling heat exchanger. You don't want to freeze it up because the air is not passing by. Also, the PLC will pick up the fault and it will tell you what damper you can buy and when it was broken, blah blah blah. This is an air handling unit. You won't see the heat exchangers and anything. You see this exhaust damper and fresh air intake damper are opening while the recirculate air damper is closing. Guys, you have to maintain always the minimum open area for the supply fan to drag the air. So they work against each other, like exhaust air damper and fresh air intake damper work together against the recirculated air damper, because if you bring more air into the premises, you have to exhaust more air and so on. If you have a problem with the recirculated air damper, you lose the possibility to recirculate the air, and this is not good. Now the HMI will show you the fault. If the programmer writes a great software and the control philosophy engineer knows his job, he will put the right program into the PLC. Again, the HMI will show you what damper is faulty. It will give you some details about the damper and some instruction what to do. But again, this is a choice. It is up to how the control philosophy engineer will choose to do his job. This is the air handling unit. This is the way the air is passing by. You'll see you have a recirculated air and you have the fresh air intake, and that air is taken by the supply air fan and push into the rooms, and then it will extract the air from the rooms. Guys, they 3 individual fans. Some people like this, I don't. This is good. This system is good because if one fan will fail, the other two will take over and will maintain the airflow. The benefits of it is that if one fan gets faulty, then in an individual chamber, the damper will isolate the premises. I can remove the fan and I can take it to repair while the airflow will be undisturbed. I don't like this particular fan because running inside the supply air chamber generates heat, and I have to compensate that heat by choosing a little bit powerful heat exchanger, because you guys, you know, every motor will generate heat. You have to know how many kilowatts of heat that motor is generating. So these three fans are good because, as I said, one failed, the other two will take over. But this type of fans will give a positive air pressure into the supply air chamber, like you see here. It will pull air through the heat exchanger, and then you'll have a positive air pressure, and then because of this you might have some leaks through the doors because the volume is very big of the supply air chamber, and what you see with the blue, it is the air leak, so you can have air leak all over the place. Unlike the other one, this type of fan is better. It's bell driven. Always you find pro and cons, but this fan will not generate as much heat because the motors are outside. This type of fans, scroll fans, generate heat inside. They an internal fan as well. Again, you can run the twins, and you can choose. Each fan would have the capability to run the system on its own. If one will crash, the other one will take over. You have dampers to segregate the faulty fans, so you won't have an air closed loop, so you won't lose the air capacity. I just want to tell you that these fans are hot. They will hit the supply air chamber, but they will run on negative pressure, which is better than the other one. I decide to segregate the spaces again. The reason I'm doing this is because if this fan will fail, I will have the capability to isolate the fan and then to replace it without stopping the production, without disturbing the airflow. As you see here now, the damper just closed, and I could remove the fan, and the other fan on the other side will push the required quantity of air. Obviously you won't see this inside, that's why we use a PLC and a HMI. The HMI will tell you like supply fan failure, and it will ask you to check the motor for electrical or mechanical failure. Will tell you the rooms which it covers by this AHUs being compromised. It will ask you to look to the pressure as well, and finally on the next page it will show you the type of the fault and where to investigate. This drawing will be the real drawings like on the paper, and any modification will be subject to change control. So an electrician will consult this drawing, and the HMI will tell you exactly where to go. So sometime the fans can stop, but they will not be faulty. The electrician is inclined to go and to check the fan motors, but the programmable logic control will do a self-assessment, and the HMI will display the fault. So this type of failure will be picked up by the PLC. The motor which is still healthy will take over, will accelerate to compensate the capacity. But this time, as you'll see, you have a supply fan failure, and you have the L3 power supply 280 volts. And now the HMI will show you to check the power supply to the VSD. So it is not the motor. Actually, this intuitive system have the capability to tell you what's wrong, to guide you correctly, what to check and where. And if you'll do this, you'll have a healthy AHU. Now, what you'll see here, this is a disastrous failure in which a technician didn't take action when the first motor failed. He just ignored it. And the second motor failed. Now you lost the entire airflow, the entire cluster is compromised. You see all the rooms are on red. You lost the pressure. That will lead to deviation and root cause analysis, which will lead to probably many other things, but not technical. Now the HMI will tell you the date when the motors has been stopped. One is on 16th of July as an example, the other one on 19th of December. And the root cause analysis will list to the technician, to the management, and question will be related to why action has not been taken in time. So one motor have a problem with a electrical or mechanical failure, while the other one have a power supply. And again, on the next page, the HMI will have the capability to direct you to the right area to investigate this system correctly. So one motor have electromechanical fault, where the other one, it is a power supply. You have to check the power supply from the MCC to the variable speed driver. And this is great because we'll cut a lot of time and this will be captured. And as I said, once you repair, you will have a healthy system, but do not confuse this with a localized problem. Like in this case, room 207 have a problem. It doesn't mean the air handling unit have a problem. This is a localized problem. You press on that room and you'll have a legend and it tells you the door is open. That's why you lost the pressure into the room and that's why you gain the temperature. So this is one of the problem. This type of ventilation is the one we use the most. Again, this fan doesn't overheat the supply air chamber, but they pro and cons. You can have a broken belt, you can have a mechanical failure which will affect the entire system. One bearing through the belt will stop the entire system. If you have only a simple electrical failure, the motor will switch from one to another, then the rooms will tell you it's been a glitch into the system. So you have to reset the rooms. So resetting the rooms means you acknowledge the failure. The HMI will tell you, check the motor for electrical or mechanical failure. So when you will go to the next page, the HMI will show you what to investigate. Or if you have, like in this case, a supply power failure, the HMI will ask you to investigate the supply. So actually will direct you where you're supposed to go. This is the beauty of it. If you have a broken belt, the new type of inverter have the capability to capture that, to send an instruction to the PLC, and the PLC will send data to the HMI, and the HMI will display a broken belt failure, and then also on the next page it will tell you what belt we're using and so on. This again, it's a disastrous failure in which a technician was reckless. He didn't repair the first motor, wait until the second one went down. The PLC will capture this, the SCADA will capture this, and it will show you what to do. And if you fix this, you'll have a good air handling unit. Now guys, please stay with me. You can watch my other videos. You can learn more about heating and cooling strategy, what happens when you run the heat exchanger below zero while the room it is dry or wet. You'll find out how the relative humidity will affect the heat exchanger and what affects the relative humidity, all this relation between the temperature, air solubility, etc. Here you will learn about heating and cooling on the same AHU, how they affect each other, defrost with steam, and the ratio before and after the heat exchanger. Thank you very much for watching my video, and as I said, just scroll through my other videos. They free. I don't ask for money for absolutely anything. I'm just sharing with my fellow colleagues some of my experience I gained across the years. And if you want to criticize or to make some comments, you're very welcome. I'm not perfect. I do this because I like it in my free time, and what can I say? Thank you. Good luck with your job.